All right, we've got an application here. Putting stuff in the calculator. We have some years and we have tuition. And this isn't Jefferson College tuition. This is out of the textbook. I don't even really know what it is. I didn't read the details. I imagine it's average tuition at state-run schools or something like that. We're going to look at how to put this into the calculator, how to find the regression line, how good a fit it is, and use it to make some predictions. Got the notes down there. First thing, before I put stuff in the calculator, I'm not putting in year 1997, right? We're going to let 0 represent the first year, and then our x value is going to be the number of years since that first year, just like we've been doing all semester. So to put this in, go to Stat, Enter to choose Edit, and that brings you to your lists. You're going to put the year in list 1, and then arrow over and put the tuitions 9703 in list 2, 10115, etc. Right? Be careful to type them in correctly, and also make sure you've got the same number in each list. If the lists aren't the same length, this won't work. First thing I want to do is look at what we call a scatter plot. I want to look at these points on the graph. So I want to go to Graph and then Zoom. Two ways to do it. You can either hit 9 or you can scroll down to Zoom Stat. And that adjusts your window automatically to show all of the points. Just like we've done in class with our word problems, we had to adjust the window manually. When we're talking about graphing these points, we do have that zoom that does it automatically for us. And we can see there's our tuition to first year, second, third, fourth, fifth. And we can see the trend. My math lab is going to ask you, it's going to give you a couple pictures and say which one of these looks most like what you've got there. You're not going to have to type all that stuff into my math lab. Now let's do the regression. I want to go to Stat again and over to Calc. And I want to ask it, what's the equation of the line that does the best job of going through these points? And that is what we call linear regression. We're going to find the equation of a line, and then later we're going to find the equation of different kinds of graphs like exponential or polynomial. But for right now, I want linreg. And just hit enter. It knows to use list 1 and list 2. Now we've got y equals ax plus b. A is 583.9 and B is 9674.8. What that means is that the line that does the best job of fitting through this data is the line y equals 5, 8, I'll just round it off to 4 times x plus 9, 6, 7, I'll round it up to 5. Okay, y equals that is the line that does the best job of going through that data. And how good a job does it do? Our R value here is 0.989. That's very good. That's our correlation coefficient, 0.989. My math lab will ask you, is that a good fit? Yes, that's a very good fit. Remember, if this is close to 1, it's a good fit. If it's a very small number, close to 0, it's a very bad fit. Now, a couple things we need to look at here. If you're looking at your calculator and you don't see an R squared and an R, you need to do this. If you do see an R squared and an R, you don't need to do anything. If you don't see the R squared and the R, go second, 0 for catalog. And you'll see a whole bunch of things. You want to arrow down to a line that says diagnostic on. Hit enter again, and diagnostic will be turned on. Now when you go to Stat, over to Calc, and down to linreg, you should see the R squared and the R. I have no idea why we have to do that to get that information, but we do. All right, now let's go to our graph, and we see just those points again. We don't see the equation. And the reason for that is that we didn't put the equation into y1 to graph it. Let's do that. We could type it in there, or we could do it this way. I'm going to do it this way. I'm going to go to Stat, over to Calc, LinReg, and then I'm going to Store, which is, where does store go? It's right there. I'm going to store the result. No, I don't think I need to do that. I think I just need to do Stat, LinReg, and then vars, arrow over to yvars, enter for function, enter for y1, enter for execute. It gives us the same stuff again, but now if you go to y1, your equation should already be in there. And when you go to graph, you should see that line, and we see how good a job it does of going through all of those points. It doesn't exactly hit them all, but it comes pretty close. And we already know that because we had a high correlation coefficient. Let me show you that one more time. Stat, Calc, down to LinReg, enter, or you could just hit 4. And then if you practice this enough that you don't have to think about it, it's really easy. It's vars, arrow over, enter, enter, enter. And that gives us our graph. MyMathLab will also ask you this multiple choice. It will say which one of these resembles the graph that you get. So you need to be able to do it, but you're not going to have to copy it down or anything. Now, how can we use this? Well, if I want to see what this graph predicts for a particular year, I can go to Trace, and notice it's giving me the point 09703. That's this point right here. That's coming from, that's point 1 from list 1, list 2, you can see up there. And if I use my side arrow, it's going to keep giving me points. It's going to give me the data from this table. That's not what I want. I want the line. So in order to get to the line, I can hit either up arrow or down arrow, and it will toggle between the points and the equation for the line. So if I'm on the line there, now I can move along, and you can see the cursor move, and it will tell me not what the table says, but what the line would predict for any particular year. So if I want to know what the line would predict for 2008, well, how far is that from 1997? That's 11 years from 1997, and 2020 would be 23 years. Well, if I try to put 11 in here, it's going to give me an error because my window is only set up to go from 0 to 4. So I got to set my window first here. Go to window, and it's going from -0.4 to 4.4. I need it to go to 24. So what that's going to do is cram the data over here on the side and give me more years out to the right. Now I can go to Trace, arrow down or up to get to the equation of the line, and put in 11. And it tells me that if this trend continues the way it was going, then in the year 2008, our tuition would be $16,097. And if we went to this year, to 2020, then our tuition is up to $23,104.50. And I don't know how many decimal places MyMathLab's going to ask you for, but this is going to be the process for the problem. Put the stuff in the calculator, get the regression line, find out how good a fit it is, graph it, and use it to make some predictions. That's what regression's all about. We'll do a couple more of these.